Can we do some audio check? Can you hear me?
Audio check, audio check.
Hi, Tolas, I hear you fine. It's good. Good that we have something working. So let's wait for David. Oh, David is here. Very good. Hi, David. Good morning. Hi, David. Good morning. I see you are sharing the note file. Very good.
Good morning, Jonas. Good morning, everybody. Need to figure out whether we've got a notepad that works here.
For taking the notes.
Hang on a minute. It wants me to sign in. Let's see what happens here.
We have the usual Hedge doc if that's what you are looking for. Or...
Yeah. Hang on. We're going to try this again. All right. Let's see. Let me go dump the agenda into the notepad. That's probably useful. All right.
I gave the link to your email with the agenda to the chat window if people want to take a look offline.
All right. Let me go switch over to the agenda then. Okay. I see. Hang on. If we do that, and okay. Turles, could you check, is that notepad link the place where I just pasted the agenda?
That's exactly what I did, yes.
Oh, wait a minute. I'm wondering if we've got two different windows here. Help.
Yeah, that's exactly why I,
Oh, Lord.
you can say open a different tab and then move the tab and so on.
Just a minute. No, it is okay. It is the same window. It just I had some funny interactions with Hedgedoc wanted me to log back in again. I thought for a moment it was going to send me off to some other file. Okay, I think we've got it. Okay. All right, let me go switch back over. So I guess we ought to go ahead and get started here. I think I see 18 people. Let me quick switch over. This is a open working meeting of the DETNET working group on the enhanced data plane. Let me go switch back to the Note Well slide. So this is the IETF Note Well slide. By participating in this meeting, this applies to you. You're expected to have read and understood this. Okay. Hang on a minute here. All right. Alrighty, and if we do that and that. I'm sure there's an easier way to switch windows. I will admit my coffee is not working this morning. Okay, this is the agenda that was posted to the list. It's similar to the last meeting. Quick intro, which we're in the middle of now, including the Note Well slide, and a general sort of discussion of process-oriented topics. How do we make progress from here? And we have a presentation coming up from Peng, let's see, Xiaofu, I think, on deadline-based forwarding. And I see Xiaofu is on. Good. Okay. Anybody want to bash the agenda?
No, as I told you, if necessary, if we have the time, I can follow on with a TCQF, but no hurry.
Okay. I think one of the things we learned from the last meeting was that it's probably better to simply have one presentation, because what happened, we went into that meeting thinking that maybe we could do two presentations inside of an hour and a half, and then A, we didn't have an hour and a half, and B, to allow for full sort of presentation and discussion, even though only 30 minutes of slides had been prepared, we really needed to allow an hour. So I think if we go one at a time, we'll be good. And that means we've got going to have a few more of those going forward.
Hello? Can you hear me?
You want to say something, Peng?
Yeah, yes. Can you hear me?
Yes, we can hear you.
Yes, we got some proposed change of the requirement draft, but the authors haven't have so much discussion, and maybe we can have a look at it proposed by Zheng Dong, but I'm not sure if he can speak because he is in the ITU meeting. Yes, so there are 3 slides of the requirement draft.
Sure. If you want to talk about revisions to it, because one of the things I would like to get started after this meeting is to start looking at how the TSN queuing and scheduling mechanisms fare against the requirements. It's not so much that we expect them to meet the requirements. We expect them not to meet most of the requirements, but we ought to get started with something that is known and neutral with respect to the proposals, to make sure that we understand what the requirements draft says and what it means to, and start to get some experience with what it means for a mechanism to meet or not meet the requirements. So Peng, you want to talk? I will go ahead and stop sharing. Do you want to talk about
okay,
the proposed revisions?
Yes, because just some chance, maybe we can just take a look at it, and if pre comments on it is good, but we don't really spend so much time on it. We can also use it in the main list. I mean, if we have the time, maybe 5 or 10 minutes, just to.
Sure.
Okay, sure, thank you. So, okay, should I share slides now or later?
Yes, go ahead.
Okay.
Okay. I see. Wait a minute. I see you asked to share the screen.
Yeah.
What do I have to do to say yes?
So.
Are you able to share, or is Meet Echo blocking you?
No, I can't share now.
Do you want to send me the slides and I'll try to share? Oh, wait a minute, there you go. Oh, there it is. Thunk. Try it now. There we go.
Yeah, I see it.
Sorry, Meet Echo hid the most important line from me.
Okay, sure. So here's the slides. Can you see it? You can see the slides on my screen.
Yes.
Okay, sure. So here's the proposed change of the requirement for section 3, I think, from Jindong. He proposed to add 3 requirements. First one is be scalable to a large number of hops with complex technology. And the second one tolerates the burst and this accumulation. And the third one tolerate high utilization. He proposed to add 3, so if we really add it, we will have a 10 requirement, and it's a proposed text from him. So I just want to hear more comments on it. Should we add it or merge some of it into the existing requirement? Maybe you can take some time to look at it.
Anybody want to comment? Carlos, go ahead.
Yeah, I think the I did, and sorry, as co-author, I didn't have time to work on this in the last 2 weeks. I do like this all. I think I very much liked from last time from the presentation last time and the framework overview, this notion of the what is it called? The burst aggregation in cycles, right? That is something like a worst case, and I'm not sure if they had a good reference in the document, but I hope they had, and I think that would be good to add that to number 37. I.e., maybe taking a note here to look into that microburst accumulation in circles, and add a reference to that. Don't need to change the title, right? So just as an add-on to the proposed tech TBD, look into that. Maybe the folks who presented that last week would know exactly what to add to highlight that problem, because that's exactly the combination of number 3.5. We do have rings with traffic being injected in multiple places, and then number 3.7 of the microburst problem.
Okay, sure. Here we have this requirement prevent flow fluctuation from disturbing service, and here's this text suggests to move from this one and add a new requirement here.
Right, and I'm just saying that, but we can take it offline, right? So I'll take a note.
Okay, sure.
Yeah.
Sure. Sure. So maybe you should have some time to really think about it, and if we can't really have more comments, I can stop to sharing this screen. Just to mention that we have some proposed changes. Maybe the co-authors or others we can really enhance according to it.
Yeah, the two paragraphs that are currently in 3.7 on slide 2 look like they're separate requirements, and
yeah. Okay, sure. We can move it offline, I think.
Yeah. I think we need some more discussion about whether those two paragraphs are, in 3.7 are one requirement or two or two requirements. Okay.
Okay, sure.
3.8.
I'm not really understand this one. I asked Zhendong, but he may be able to really respond to it.
Yeah, I'm not sure. I mean, I see two things there. I see certainly in some of the earlier DETNET design work, there was quite a bit of attention to scenarios where DETNET was a small portion of the network traffic. And so I think the first sentence is fine, but the assertion that the first sentence requires network planning, not sure how that relates to what we need, what we need to do in the data plane to make sure that we have a mechanism that can accommodate most of the traffic. I guess I would prefer a clean separation between what we need to do in the data plane to accommodate most of the traffic being DETNET and what needs to be done in the control and provisioning area to avoid overcommitting the network. I think those are two separate topics.
Yes, I agree with you. And maybe now we asked Zhendong to provide more description of it, I think. So okay, sorry for adding this one. We can.
I think I see Jingdong on. Did you want to say something about this, Jingdong?
Maybe he. I'm not sure. Okay, sure.
Can you hear me?
Okay.
Yes, we can.
Okay, thank you. So your impression or your opinion is that the text for section 3.5 and 3.7 those texts can be accommodated after some massage, right? And regarding 3.8, you see that requirement is more or less related to control or management of networks. Is that a correct understanding?
Almost. I think
Okay.
3.8 is, I think there are actually two requirements in 3.8. There's one requirement that basically is the first two sentences, which says that we need to accommodate network environments in which most or all traffic is deterministic. And then there's a
Right.
second requirement for network planning, which I think is separate.
Right. Okay. 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 So, so you, David, I want to ask this question. You don't want to mention uh, anything, any requirements about control or management plan stuff in this document?
That's a really good question. I've probably given a bad answer earlier, so let me try to explain my way out of this. I think we need to put all the requirements in the requirements document. This set of meetings is going to be focused initially on data plane, but I think we should capture the control and management. So I wouldn't
Okay.
want to lose it. I just like to separate it.
Okay. So then maybe, okay. Then maybe we just better remove this provisioning or network planning sort of statement here, sentence.
I might
here.
suggest writing it as a separate as a separate paragraph, and then figuring out where it can
Okay.
go. I don't think I want to lose it, but I think
Oh, okay.
network planning and queuing are two different
Right.
things.
Right. Of course. There are two different things. Yes. Okay. Okay. Let me have some more time to come up with better text then.
No problem.
Okay, thank you.
Okay.
Iju, go ahead.
Sure.
Iju, go ahead. Iju, did you want to say something?
If you are saying something, you need to unmute yourself.
I didn't unmute myself. Can you hear me now?
Yes, we can. Thank
Yeah.
you.
Thank you. So I might duplicate your comment, but I still want to mention this. The last sentence for the 3.8, basically it says to provide a scalable network planning and queuing solutions. I want to point out that the queuing solutions to tolerate, whether they tolerate or support the high utilization. I think this is a valid one because, for example, in some of the queuing mechanisms, like CQF originally tried to use the dead time, but the longer dead time we try to put, then the lower utilization the whole network can be achieved. So the better queuing solutions is able to the requirement for the queuing solution to support this, I think is valid. But I also agree that this is different from the network planning part. Yeah.
Okay, thank you.
Okay. Sure. So we can.
Sean, go ahead. Okay. Minako thinks you're enabled, but are you there?
Sorry. Do you hear me, David?
Yes. Yes, now we do. Thank you.
Oh, sorry. I agree with you. I think the network planning is also more like as the control plane foundation function. So I suggest to add move the network planning to the control plane framework, the draft. The requirement the current draft requirement, we mainly focus on the data plane, and the requirement is applied to the queuing solutions. So I suggest to separate the queuing solutions requirement and the control plane requirement. But I think the 3.8 is more like the network planning, and I suggest to move that to the control plane framework. Thanks.
Okay.
Yeah, I can also do that. Hi, this is Dong. I can also do that. By the way, that control plan framework document, is it a working document of DETNET working group?
Document, but Newburger wants just me to add some tests for the enhanced datalet to add this test to the working group working draft. So we also can add new function about the control plane. So I think we should suggest to add this function. I agree to add this function, like the lateral planning. I think it is very reasonable to add to that working draft.
Oh.
So you mean the controller
would you
plan?
please let me know? I'm sorry. Yeah, go ahead.
Go ahead, please.
Okay, thank you. Would you please let me know the title? No, not title. The file name of that draft you mentioned.
Okay, the controller plan, I think.
Controller plane framework.
I'm not sure if there's.
Yeah,
Maybe you can put that draft in the chat window. Then it might be most appreciated. Thank you.
I think Iju put it in the chat. Sean, could you check whether that's the draft you were talking about?
Okay, I will put that on the chat.
Okay.
Okay, thank you.
I put it in the notes, so check if it's the correct URL in the notes.
Well, so anyone
That looks like that looks like the right link, and it is a working group document. That might be a very good that might be a very good place for network planning material.
Okay, got it. Thank you.
Okay. And Peng, did you want to show slide 3?
Yeah, just to mention that we don't really have any more work on these two requirements of the data planning enhancement requirement section. So maybe we are going to just remove these two requirements.
Should the path selection requirement get the same treatment that maybe it belongs in the control plane?
No, it's for the data plan, but because we don't have the aligned points with technical requirement. So
Yeah, maybe I think I need to revisit that, right? I think the one forwarding plane requirement, of course, is to see that we should be compatible in what we're doing for the queuing with all the steering solutions that we currently have in our forwarding planes.
Yeah. And Charles, maybe you just described a useful generalization of what that fourth requirement currently is. Iju?
Controller, the working group document, the controller plane, there is a 4.1, section 4.1. It talks about explicit path. So we probably can check it and see whether it's already covered.
No, I think it is both. I completely agree. It is also a controller plane framework requirement, but in the forwarding plane, I'm primarily worried about the combination of multiple extension headers, for example. One for the steering and one for the QS. And that's one of the problems we need to work out.
Yeah. Okay, I got it. So the controller, that one, the working group document, actually it's talk about the controller plane. So it talks about the path computation, PCE part, and the path establishment. So I think what Thomas suggested is more like from the forwarding plane. What's the at the forwarding plane, like the not, more like source routing kind of a thing, I guess.
Perhaps
that is so slow that the audio on and off is very slow today. So fast ones, I think I need to stay unmuted. Yeah, exactly. That's what I was fearing, because I think some of the hop by hop steering mechanisms that we have wouldn't allow another independent hop by hop header for the QS. So the combination might be an interesting work item later on.
Yeah. And if I remember from the last meeting, there was some discussion of a queuing mechanism that might be only usable with source routing. So what I was wondering was whether, for the purpose of the data plane that we're working on, that what's wanted is something you said earlier, Turles, that the queuing mechanisms ought to be applicable to whatever is being done in what you referred to as the steering headers.
I don't think there is any queuing mechanisms that we could not also do with per hop state. It's just the per hop state would not necessarily suit our scalability requirements.
I was thinking that I think that's a different point. It might be worth having a list of the steering and routing mechanisms that we care about. Obviously, there's a great deal of interest in source routing, but listing all of them, or a representative subset of them, and a requirement that could replace requirement 4 in this slide would be the queuing mechanism ought to be compatible with all of them, not specific to one of them.
So that might be a good point to add the explicit listing. Yeah.
Yeah. Okay. Pascal?
Yes, to David's point, there was this idea of using the currently spent latency of the packet in the queuing, in which case it has to be on the hub, on the packet headers, or possibly on the hub by hub. If we want to signal how much latency we have at every hub. And so that would be a case where David's point applies, that it cannot be a state in the network, but has to be a state in the packet.
Yeah.
So just
very good. Thanks. Yep.
Yeah, and Pascal, one of the things we're trying to dance around here, and I'll admit it's an interesting dance, is to figure out the queuing mechanisms without committing to the design of the headers needed to carry the additional per packet information the queuing mechanisms require. So it's sort of an interesting dance where we know some of the mechanisms are going to require the information to be carried, but try not to commit to try to figure out the queuing mechanisms before embarking on detailed design of the additional headers or header extensions.
Okay, sure.
Well, I guess that given how we understand the problem, maybe it's also something we can independently start to figure out what we could even do, right, in terms of saying we don't exactly know what the fields are going to be, but go to 6-man if that's, for example, one of the working groups that would need to take responsibility later on anyhow, and make suggestions or try to get guidance. That way we wouldn't need to fully serialize it, but we could probably faster get some limits on how we could do it.
Yeah, at this stage, and that's a good enough hand wave. I think we'll likely make more progress here if we focus on what has to be carried for the queuing mechanisms. I'm not sure what the right word to use for it. It's a model of some form because we're not speccing the actual data field that have to be carried. And then, as you say, for example, for a V6 extension header, we'd go to 6-man, and we'd have something to point to that says, "This is the data we need to be carried. Please help us figure out how to do it." Okay, so Peng and Jiangdong and everybody's free to thank you. It sounds like there needs to be a little more discussion among the authors, and then please don't wait for the next meeting. Please go ahead and discuss on the mailing list and see about revising the requirements draft based on that discussion.
Yeah, we will.
Thank you for your guidance, David.
Well, thank you for your contributions.
Okay, sure. Could I stop sharing?
Sure.
Okay, thank you.
I think I just, hang on, I just lost one of my windows. Let me see if I can get that back. Okay, so there it is. Okay. So I would hope we can get the requirements draft revised, and maybe for the next meeting, the requirements draft authors could pick one of the TSN queuing and scheduling mechanisms, and just come up with an initial draft line of the matrix that shows that shows how it looks against the requirements in the requirements draft. As I said, the expectation is that by and large we won't meet them, but let's at least get started with something that is known and hopefully understood.
Well, the worst case without trying to beat up on poor TSN would of course be our very own RFC 2211.
Are people seriously considering RFC 2211 in the context of DETNET? It's a very old one.
Right, but ultimately, I would call it a predecessor for TSN ATS. Shares very much the basic concepts, and it's our own work from IETF. So that even the access to all the IEEE documents might be an issue for many people from the IETF.
The set of DETNET RFCs actually referenced the TSN docs as places to look for scheduling. Janos, you have a something to add?
Yeah. I don't get why access is difficult. IEEE standards are free of charge after 6 months after publication.
Okay.
And anyone can become a participant by subscribing to the list, like in IETF, individual participation. So anyone interested is welcome to join and can access.
Yeah.
Okay, cool.
And from in terms of a utility, from a utility perspective, the TSN mechanisms seem much more likely to be implemented. They're much more recent. I mean, the 2211 intserv is rather old, I think would be a polite way to describe it.
No, completely agreed. It just, from my perspective, foundationally, I would put TSN ATS, for example, in very much the same bucket as 2211, although obviously, some good degree of improvements of implementability at lower speeds and smaller links has been done.
Yeah, and between the two, I'd prefer to have an evaluation of ATS. I think that's likely more relevant and more useful to people when we get around to publishing something. Okay, anything else people want to talk about before we do the deadline-based forwarding presentation? Okay, let me stop sharing, and Xiaofu, go ahead. We've got at least an hour for you. So what I guess I would ask is for folks, let's take clarifying questions only during the presentation in the hopes that we can get through the slides, and then feel free to ask any questions when we get done. So Xiaofu, go ahead and share slides and get started.
Oh, thank you, David. Can you help me to share the slides that I sent you before?
Oh, okay. You want me to share them? Hang on a minute. Yes, I can find those slides, but the coffee is still taking effect, so it's going to be a little bit slow this morning. Okay, I found the slides. I got to put them somewhere where I can use them.
Thank you.
Yeah, give me a minute or two.
Okay.
Hang on, no, wrong. That folder. Okay. PowerPoint didn't like your slides. It wants to repair them. Let's hope it doesn't do a whole lot of damage to them.
Oh, so I try to share my screen.
Okay. I've got the slides that look okay. PowerPoint is warning me that it removed some content. I don't know what it didn't like, but it removed something. I believe I can share. Hang on a minute here.
Okay, I try to share
Okay.
it. This is my first time to share.
Okay.
Do
Here.
you see my screen?
It says a screen share is being started. Give it a minute.
Do you want to share? Yes.
Okay, we don't see your screen yet.
Just. Do you see
At this time?
There it is. Yes. You should
Okay,
probably go into
thank you.
slideshow mode if you can, because the slides are a little small.
Okay, I will full screen. Okay, okay, I will try to introduce the deadline queue mechanism. uh,
Can
the
can you put this
proposed
into
deadline queue mechanism.
Shafu, can you put this into slideshow mode? Some of your slides are going to be very hard to read with the entire window you've got. Yeah, the font's going to be a little small for some people.
I have taken the full screen.
Yeah, I don't. It's not sharing full screen over Meet Echo.
Sorry, this is the first time to share. So how about this time? Is it still not the full screen?
If this is the best you can do, let's see if it works, folks. If his font is too hard, is too small, too hard to read, please let us know. But let's just go ahead with this. Go ahead.
Okay, let me see.
This cannot
Okay.
be changed to full screen?
Yes, I tried to change it to full screen, but it seems that you have seen that it's still not the full screen.
Yeah, we're still not seeing full screen. Hang on. Let me see if I can get full screen off of my system. So hang on. I'm going to stop your sharing, share my screen, and let's see if we get a better result.
Okay.
We want that one, share, and okay. Are you seeing full screen?
Yes.
Yeah, I see. Thank you. Thank you.
Okay. All right. Okay, let me know when you want the slides
Okay.
advanced.
Okay, for this slide, so I will try to introduce the deadline queue mechanism. The proposed deadline queue mechanism is a variant of EDF. According to the public literature, an EDF scheduler which always selects the packet with the earliest deadline for transmission. It is an optimal scheduler for a bounded delay service and can support the delay bounds for any set of connections that can be supported by some other method. But the disadvantage of EDF scheduler is that queued packets must be sorted according to the deadlines, requiring such operation whenever a new packet arrives at the scheduler. Here, the meaning of variance is including the following topics. We use 5 to replace the list for each of hardware implementation, and without requiring queued packets to be sorted strictly. Instead, multiple queues are sorted by priority and dynamically rotate the priority. And introduce non-work concern behavior for jitter-sensitive service, besides the existing work concern behavior of EDF. And the last, using latency compensation to replace the reshaper inside the network. Oh, I have not the control, so go to next, please.
Okay.
David?
Whoops, what happened there?
Next page.
Next, there we go. That one.
Oh, thank you. So this is the overview of the queuing mechanism. The idea of deadline queuing rule is simple, which is to maintain queues with countdown time attribute to store packets with the related residence type. Thus, we note each deadline queue has countdown time that is decreased by rotation interval, and the sending duration is 80. 80 is n times that of Ti. Ti can equal to 80, but it is usually a smaller value to let the city sensitively perceive the residence time of the flows. Based on the maximum deadline that a node can provide, the larger the 80 value, the fewer queues are required. Go next slide, please. Okay. The queuing rule is that a packet with allowable queuing delay, computed by planned residence time and accumulated residence deviation, we put to a deadline queue, meeting the condition that the CT is less than or equal to Q, and Q is less than CT plus AT. Q equals to D plus E minus F. Here, D is the planned rest time, which is computed by end-to-end delay minus the total link propagation delay, and then divided by the hop counts. D also termed as delay level. If AT is close to 0, then it is exactly the traditional EDF. Go next slide, please. So there are two types of deadline schedulers, each with isolated queues and isolated service rate. For interim mode, it has work-conserving behavior. Packets are sent as soon as possible before the deadline. While for interim mode, it has non-work-conserving behavior. Packets are held until the deadline. Whether it is an in-time or on-time queue, if the CT value of the queue becomes 0, it has the highest priority and immediately get sending authorization. For in-time mode, even if the CT value of the queue is not 0, it can also get the opportunity to send packets as long as queues with high priority are empty. While for interim mode, if the CT value of the queue is not 0, it cannot request sending authorization. But for interim mode, due to the time required for packet sending, you should pay attention to the extent of the exceeding the deadline. Therefore, we further introduce strict on-time and loose on-time mode. Go next, please. So the key question is how to guarantee delay. The answer is the schedulability condition. Observe a specific node. Suppose that the deadline scheduler of the outgoing port has a service rate C, which can be less than or equal to the port bandwidth. For all concurrent arrived flows, with arrival constraint function AIT and planned residence time DI for flow I, as long as the following condition is met, the scheduler can successfully send all packets before the deadline. So I will give the more description about this picture. Go next slide, please. Here we give a rough proof for the in-time scheduler with work-conserving behavior. The proof process is similar with that provided by the public literature, except that we introduce a new factor that is rotation interval Ti. Because the proof process is trivial, so I won't go into too much detail. But the basic idea is to calculate the workload that must be sent before the observed packet. That may including some packets with the same delay level arrived simultaneously as the observed packet, and some packets with higher delay levels arrived simultaneously only in the future, and some packets with a lower delay level but arrived more earlier than the observed packet. Please go the next. Therefore, it's important that the actual arrival traffic of each level and the node must not exceed its constraint function, so that the scalability condition is always met. Otherwise, it should reshape traffic to obey the constraint function, or reward or punish the priority of the traffic by latency compensation to identify the legitimate emergency traffic. We suggest this option. The value of the parameters of the constraint function of each delay level construct the delay resource of that level. The following figure A and B shows the legitimate arrival and illegitimate arrival case. Please go to the next. So for the conditions for leaky bucket constraint function, if the arrival constraint function is leaky bucket, the conditions is as below. Especially when the bandwidth of each level is negligible due to large burst interval and small burst size, then the maximum burst resource of each level may reach the full value. Here the full value is say multiple AT minus F. In general, the bandwidth of some levels cannot be negligible. That causes the burst resource of the low priority level cannot reach the full value. The delay resource is the enhancement of the traditional bandwidth resource, which contains the additional burst resource for each level. Please go to the next. So this is an example for the extreme case that all delay levels bandwidth resource are approximately zero due to large burst interval, and each level may have burst resource with the full value. So if concurrent bursts of all levels with the full value arrived, the burst 1, burst 2, burst 3, and so on will be sent one by one in sequence. Please go to next, please.
Sorry, I didn't understand that. What the bandwidth is zero because of the large bursts? Can you rephrase that?
Yeah. For example, because all class the burst resource and the bandwidth resource of all class will meet the scalability condition. So there is an extreme case. Okay, this is just an example. There is an extreme case that the bandwidth resource of each deterministic level is approximate 0. For example, the burst interval is too large, for example, 1000 bytes 1 year.
Turles,
This is
if it
just an
helps,
extreme example.
Turles, if it helps, as Shafu said, it's a very extreme example that he's basically set the steady state bandwidth of the flow to 0, and all of the traffic that is flowing is bursts. To sort of talk about what's
Yes.
the burst behavior with this scheduling mechanism.
But what exactly are the
Yes.
parameters? I thought that, for example, in this example, you said the interval between the bursts is 1 year, but that is not a flow parameter. The flow parameter is a still explicit rate that would only allow you to send these bursts very rarely, like once a year. So you still need that bandwidth, right, to express the distance. True?
Okay, okay, the normal example we will show in the next slides. This is just an extreme example.
So the parameters by which you characterize the flows is the burst size and the rate. And in your example, the rate is very low, so that the bursts can only happen very rarely. Is that it?
Yeah.
I
Yes.
think you're coupling. Okay.
Okay, I'm sorry. The T-spec parameters, for example, it may have the burst interval and the burst size.
Okay.
And for example, some other parameters, the maximum packet size.
Do we have slide numbers here?
Okay.
To put my comments in? We don't, right?
No, we don't. I'm sorry. It's that might have been what PowerPoint took out. I got this weird warning that said it dropped some content on the floor, but it didn't tell me what it dropped.
Okay, we see the example 2. This is another example for the case that some delay levels bandwidth resource cannot be negligible. For example, burst resource of D1 is 4 value, and the bandwidth resource of D1 is half of C. We will see the service rate of the scheduler. That means burst with 4 value per 280. And all other delay levels have the approximate bandwidth 0. Then all other levels may have upper limit of burst resource as half of the 4 value. So if concurrent burst of all levels with the upper limit arrived, the first burst 1 and the burst 2, burst 3, and then the second new arrived burst 1 and burst 4, burst 5, and so on will be sent one by one in sequence. And there may be other normal examples that I have no time to show them respectively. We will give more description in the draft. Okay. So if no new questions, please go to the next. The above examples show the scheduling result based on the ideal fluid. However, in reality, microbursts often occur. The following figures show several cases of the arrived traffic based on the example 2. Figure A is the ideal fluid that all concurrent bursts arrived obey the constraint function. Then the schedulability condition is met. While in figure B, there are 2 bursts of D1 level, one of which came too early. It will be punished and given a lower scheduling priority based on the latency compensation. In Figure C, there are two bursts of D1 level, one of which came too late. It will be rewarded and given a higher scheduling priority based on the latency compensation. However, Figure C only happened in theory for interim mode because no packets will be sent exceeding the deadline and to be late. Okay, please go to the next slide. Now we took a look at the untimed conditions. The untimed mode is a bit complex because it is also it does not cause the arrival curve to exceed the expected traffic contribute function. But it is non-working consumer behavior and with the opportunity to send packets. Cause some packets may exceed the deadline. So we suggest in-time or loose on-time mode applied on the transit nodes and strict on-time and egress for low delay kit service. Okay, please go to next. So this page is for buffer size design. The countdown type of each queue is dynamically changed, so it is not bound to a fixed delay level. It will actually store all levels of traffic during its city deployment process. The following give an example. We see that at T0 plus 10 microseconds until to T0 plus 90 microseconds. The D100 and D90 and D10 level traffic will all put into the same QA. So based on this, we will give the buffer size design. Considering the stability condition, that the sum of bandwidths of all levels must be less than the service rate. The buffer size is simply designed to the full value, that is C multiple AT minus M. According to the Nikkei bucket contribute function, the burst resource of any level has the upper limit. It may be the full value if all higher priority levels have negligible bandwidths, or it will be more small if the bandwidths of other high priority level cannot be negligible. Please go to next page. So for the admission control, admission control and the ingress node is a basic operation for this proposal. In general, the admission control is based on the Nikkei bucket place on the incoming port of the network entry. The bucket depth should be set according to the reserved burst resource, and the bucket read should be set according to the reserved bandwidth resource. Based on the resource reservation and admission control for each pass that passes through the same observed link of a transit node, the concurrent arrived traffic will meet the schedulability condition. The microburst traffic from a specific path, as shown in the former example, will be punished and get a large a low queuing delay, so that the load violated the arrival constraint function. Here we can see that the latency compensation exactly play the role of receiving and transit nodes. Please go to next. So this is an example that several buses from the same flow arrived at the ingress P. According to the admission control, some buses, for example, bus 2, 4, 5, may face more shipping delay than others. We should note that the latency compensation must be based on the shaped traffic instead of the original traffic. Okay, please go to the next page.
Quick comment. This slide's a little bit difficult to read because it appears to show traffic departing before it arrived. I assume what's happened is the time scale on the bottom of the slide is actually shifted right a little bit with respect to the received row.
Yeah, exactly. The six buses belongs to the same flow. The arrived time of each bus violates the T-spec. For example, once the bus 1 arrived at the incoming port, that is termed as UNI interface. Suddenly, the bus 2 also arrived. Then the combination of bus 1 and bus 2 may exceed the bandwidth, may exceed the reserved bandwidth. So the bus 2 must be shipped. For example, plus S1, the shipping delay, termed S1, then to go to the outgoing port and to be scheduled by the deadline scheduler. I'm not sure if I explain clearly.
So does it mean this slide is showing a problem and not yet the solution?
This is just show the admission control of the bus. This problem may faced by any queuing mechanism. So we will show more details about how the mechanism to address this problem.
Yeah. So Shafu, what I was commenting on is, let's take a look at burst number 3. Just because of the way you've laid the slide out, the number 3 on the received line is to the right of the number 3 on the sending line. Now, clearly that's not what happened. The packet has to have been received before it was sent, but it does make the slide a little difficult to understand.
Okay. Okay. The figure is not very good to show the behavior of the process. Indeed, the bus 3 is the bus 3 is put to the queuing subsystem without any shipping delay, but it has faced more queuing delay at the subsystem, at the queuing subsystem.
Yep. Okay. All right. Ready for next slide?
Okay. Yeah, please go to the next slide. So for overpollution analysis, we see overpollution generally happens at the case that a service flow has a large bus size. Even the service flow may require a small bandwidth due to large burst interval that we have given some example before. The resource mode of deadline queue mechanism separate the burst resources and bandwidth resources to avoid overprovision issues. For example, a flow may allocate burst resources of a specific level with the full one, but it does not mean that we have to send the full traffic on every window of AT. In fact, other windows of AT can send bus from other levels. Here we call the burst we call the burst size per AT is the overprovision bandwidth. So the following figure gives the extreme case that showed before that each level has a full value burst size and sent one by one. But we will see that, for example, B1 send in the D1 duration, but it does not mean that in the next AT it should still send B1. Okay. Please go to the next page. Thank you.
Hang on a minute. There we go.
Okay. So this page is the summary of how to guarantee delay. First, we should partition delay resources for each delay level and the outgoing port according to the schedulability condition. That is, preserve the parameters of the arrival constraint function of each level. Second, execute delay resource reservation on each port for each path and control plane. 3. Execute admission control and network entry to let the admitted traffic obey the constraint function. 4. Execute latency compensation in the network to identify the legitimate arrived traffic that still obey the constraint function. Okay, that is the summary of how to go guarantee delay. Please go to the next page. Here is in fact, is an issue of the latency compensation. We found that. So just describe how to address it. The latency compensation may cause two packets belonging to the same bus to be out of sequence. For example, we take a look at the picture. When the source send the packets, for example, packet 1, packet 2, which were originally back-to-back at the source, but arrived at a transit node one after another due to different interference delays. So packet 2 hopes to be back-to-back with packet 1 again by latency compensation with a smaller queuing delay. However, the CT value of the queue is not decreased in real time, so that when packet 2 wanted to insert to the queue, the CT value seen by packet 2 is the same as that seen by packet 1. So the packet 2 may put to the queue before the packet 1. So that is the disorder happens. So how to address the issue? We give two options. One, the first option is by packet ordering function that is provided by the DETNET architecture. And the second option is we introduce a OGO, the order guarantee object that is maybe per flow or per incoming port plus class or some other objects. Okay, please go to next. So this page is the partially upgraded scenarios. In partially upgraded case, several board nodes are upgraded to support the deadline mechanism. A deadline path consists of several upgraded board nodes, for example, R1, 2, 3, 4, and a traditional SP domain. SP path should contain few hops with the bounded latency per hop. According to the public literature, if SP domain contain more hops, the bounded latency may be not so good. If unreasonable setting of DS field, it may get a large latency. The legacy device in the SP domain may or not merge and insert the deadline information in the packet. The board nodes decide what to speed up or hold according to the reasons deviation information of the packet. If the traffic experiences less latency within the speed domain, strict untime mode will work to achieve the end-to-end JIT target. Okay, please go to next page. So this table gives a checklist for this proposal, the evaluation of the matching degree to the scanning requirements. I will not go much in detail to each item. Basically, we have not found the significant issues for this proposal that match the requirements. Okay.
So you're saying no time
Okay, that was the
synchronization required. So can you say how the router knows the deadlines for a particular packet? Are they from state or in packet?
Yeah, there's a state in the packet. In current phase, we introduce a local offset time that is carved in the packet to indicate each node for the scheduling, for the deadline scheduling. The local offset time is an average time that is applied to each node. As I described before, it is computed by the end-to-end delay minus the accumulated link propagation delay 10 divided by the hop counts to get the average residence delay.
Yeah.
But for in the future, we can also carry deadline stack in the packet. If some node we schedule based on different residence time.
So the timestamps for the deadlines in the packet
Well, hang
are...
on. Turles, timestamp's not a good word to use.
Okay. The deadline values
bingo
in the packet are relative to the arrival time of the packet at the local router?
The arrival time, in fact, is a dynamic time that determined by the packet when the packet arrived at the node is set by the node dynamically.
And then the deadlines are just the incremental amount of time in which the packet can be sent from that arrival time.
Yes. Yes.
So I think the crucial word there was relative. Shafu, let me check my understanding. You don't need to do wall clock time synchronization, but you are depending on on limited clock skew. So the routers one router may think it's 12 a.m. Another router may think it's 5 p.m. But as long as they both advance, so that they both advance 5 minutes in the same 5 minutes, you need that. Is that correct?
Yes, that
Okay.
that is also another word is the frequency synchronization.
Hmm. Yeah, and it's synchronization is not a great word. It's there because it's more of bounding clock skew. High quality oscillators will do that without having to synchronize the oscillators.
Yes.
And I think the mechanism we saw in the last meeting has the same class of assumption. Didn't need the global wall clock time synchronization, but was depending on limited divergence in clock skew. Okay, anything else, Chef? Is this your last slide, or do you have more?
Yeah, this is the last slide. We welcome any comments and questions.
There we go. Ah, well, no, you had one more. Here we go.
Yeah.
Okay. Jinu, you wanted to say something?
Sorry. So you have two modes, in-time mode and on-time mode. As far as I understood, one of your mode does not guarantee the latency bound.
Yeah, for strict on-time mode, it may not guarantee the delay. As I just described before, if we need some packets exceed the deadline.
Could you go to
So
that slide? Maybe it must be around page 10 or something, if possible. Page 10, maybe.
Hang on a
Or
minute.
around.
I got a pile of windows here. I'll get there.
Okay. Thank you.
Just a minute. You wanted page no, not that one. I
13.
don't think.
Yeah, page 13.
13. There we go. Okay. Here, we'll
Good.
even blow
Thank
it
you.
up.
Yeah. So the on-time mode cannot guarantee the latency bound. Then
yes.
how does it guarantee the jitter? If it doesn't guarantee the latency, how does it guarantee the jitter?
That means that we don't apply the strict on-time on every node because we found that it does not make sense apply on-time mode on transit node, but it makes sense apply it on the egress node. So we suggested that in-time mode for low delay service that applied on the transit node. If we hope to get the low delay jitter, then we just apply the on-time mode on the egress, but not on the transit node.
Okay. I don't think I have fully understood your answer, but okay, we can discuss it offline. My another question is that, yeah, as far as I understand, there is a very well-known scheme called RCEDF, that's a rate-controlled earliest deadline first, which was first introduced by the Ferrari. Yeah. And in that scheduling scheme, they combine two things. The the traffic shaper for each flow, and then earliest deadline for scheduler. That scheme can guarantee the latency in each node, in each and every node. I don't quite understand the difference between that RCDF and your scheme, to be honest. Could you explain a little bit about that? Thank you.
If I understand your question correctly, the scheme you just mentioned rely on the receiving operation on each transit node, but this proposal do the same thing based on the latency compensation. That is
Yeah, but the
actually
latency
play the
compensation.
role.
Yeah, the latency
Okay.
compensation to me is another name of the shaper, because you actually hold the packet until it is
Yeah,
eligible,
yeah,
and after that time the packet
yes.
is released. That is the shaper, isn't it?
Yeah, it has the same effect of shape, but it is not the shape because uh, the the buffer uh, the, the the buffer that is used for shipping is exactly the queues of the queuing subsystem is not from the shipper.
Oh, the queue is not based on per flow, so that's the difference.
Yes.
Yeah, but I mean, even if you have interleaved regulators like in UBS, it's not per flow.
Right,
The
that's what
main
I was
thing
about
is
to
that
tell.
you don't have the per flow state, that you need to read, calculate, and update on every hop. Right? The shape, even the interleaved regulators, they have per flow state with two variables that they need to update on every packet arriving. Read, calculate, write. Then you have a deadline, effectively, from which you send.
Mm,
So that's
I
why,
I
and I
I
think that's also what RCEDF would be doing.
I I think the key difference between the RCDF with this proposal is that we have not explicit reshaper that is placed before the scheduler, before the deadline scheduler. Anyway, you may since you may think that the packet is stored in the queue, it was wait to send, and that is face some delay. But this delay, I think it is the queuing delay, is not the shipping delay.
You know, are you is your question answered?
Yeah, just one more question is that the shaper and the scheduler can be combined. Uh, those are the known facts that I understand. But in this implementation, the because of the shaping aspect of the scheduler, the non-work conserving behavior is natural to me. Can you make it work conserving even with the latency compensation algorithm?
Yeah, based on the latency compensation algorithm, for a specific packet, it will get a low queuing delay that may be rewarded or punished and then put to the related deadline queue. The allowable queuing delay is just the priority, the scheduling priority of the packet, but it does not mean that for interim mode it must to wait the corresponding time for equal to the queuing delay. It's just a priority to distinguish who is scheduled first and who is scheduled second.
But well, I don't fully understand. But if I
Sorry.
try to make myself understanding, then in that case, as you just mentioned in maybe page 19, the packet order can be flipped. Yeah, I like that. Am I right? I think if you put those packets in separate calendar queues and delay some of the calendar queues behind, then the packet service order from the same flow can be flipped. So you need
in this page. Okay. So in this page, we just say the disorder by later compensation. If this issue is addressed, that means that packet 1 and packet 2 will be put to the same queue back to back. That is as the back to back when they are sent from the source node. So I don't know if I have answered your question.
So you need packet reordering function. So you are working on those issues.
Yeah. Yes. Yes.
You are working
we
on that
must
issue.
address it. Yes.
So this is not a complete work. It is under construction.
Indeed, we have given the OGO description in the draft to describe how this issue is addressed.
Okay, I think I understand. Yeah. Yeah. Packet order flipping is a well-known phenomenon when you are working with work conserving scheduler. When you try to make those priority queue-based solution to work in a core network, then you have to face with that packet order flipping problem. Yeah. Okay. Good luck. Thank you.
Thank you.
So I was trying to understand, this mechanism is your original work, or is it an adaptation of a pre-existing mechanism, let's say, with respect to the calculus with which you're describing the latency, the bounded latency?
Indeed, our work is based on the existing mechanism. However, just like you work a TCQF based on the existing CQF, the existing mechanism may not be appropriate in IPMPS network. So we have to some adaptation to let it work.
Well, I was yes, I mean TCQF is a very simple calculus, right? So in this case here, I'm still not sure that I fully understood the calculus. So I was wondering where the proof for the calculus was done. Was that done by you for this work, or was that done earlier in some other research paper?
Yeah, the proof is done earlier in the reference paper. I have given the reference link in the draft.
Yeah, there is a reference link. Okay. Yeah. So the other comment I had was that it would be interesting to understand um, the size of the deadline, the minimum and maximum deadline that one would need, in your opinion, for, let's say, a network with 100 gigabit links and let's say 15 hops.
Hmm?
Well, so right, so the deadline that is in the packet will need to have some resolution. It could be in microsecond or whatever the unit of resolution is. And then what is the maximum size that it could have, right? So it would be good to get some example, because when we want to design a header, it would be good to understand what size of data we would need for a long path with many hops to do this algorithm.
Okay, and for this question, we have give IPv6 option that to describe how to carry the information. In my initial work for this, we suggest the 3 bytes to carry the planned residence time. That is all consistent with the delay performance of IGP extensions RFC.
That is 3 bytes for the maximum deadline, right? Not for the minimum.
I'm sorry, we don't distinguish the maximum deadline and the minimum. I'm not sure it is necessary to distinguish that.
In the non-work conserving mode, I thought you do have a minimum deadline and a maximum deadline for a hop. Is that true?
Yeah.
So you would need both of these parameters to be specified?
Sorry, if I understand the question correctly, whether it is in time mode or untime mode, we have a single planned residence time that is termed D. Yes, for this in this picture, we have seen the D equals to 30. In 10, if for untime mode, the packet, for example, reach the equals node, the accumulated residence time deviation that is termed E. E may be a large value, but we think that the 3 bytes will meet the requirement.
So wait a second. So in one mode, the hop gets a deadline, which is the minimum relative time, and the packet must not be sent before that. And in the other mode, there is a maximum deadline, and for a particular hop, you only need to signal one of the two values. Do I understand that correctly now?
Yeah, the node should advertise the deadline capability. For example, in this picture, the minimum deadline is 10 microseconds and the maximum deadline is 60 microseconds.
How is that a node parameter? I thought no, I'm asking about the semantic of the parameter that the packet carries for a hop. That seems to be the maximum deadline for the hop or the minimum deadline, right?
That is the deadline, the capability of the node. But for the deadline information that carried in the packet, that is defined in the IPv6 option that the in the draft we give the head information. You just mentioned that for the node capability, yes, we should advertise the capability of data information. For example, the minimum the minimum countdown time, the maximum countdown time. That is indeed the link capacity. For different links with different capability.
Yeah, no, I wasn't asking about that,
it
so
will
that's fine.
Advertise different information.
No, I was maybe I was confused in the first few slides, but it sounded as if a particular hop may for the packet either ensure that the packet is not being sent earlier than this minimum deadline that is carried in the packet, or it is not sent later than the maximum deadline for the hop in the packet.
Correct. What I think I understood Xiaofu to say is that there is a deadline. That's the D in this figure. And then if the packet arrives well before that deadline, the mode choice at the node is whether to opportunistically send it onward well before or try to delay it and send it just before the deadline. That's the difference between in time and on time.
But wait a second, didn't we earlier say
Yes.
that the deadline is relative to the arrival time? So how if the deadline in the packet is relative to the arrival time, we cannot know if it arrives before or after some deadline.
We assume that the link
far as I-
propagation delay is fixed. So is that anyone?
Yeah, I think in this mechanism, every node in the network has to share the time information. I would not call it synchronization, but they have to have a common clock. Thank you.
Right. The clocks the clocks can't drift dramatically. If they do, weird things happen.
Then we do not have relative times in the packet header, but we have absolute times in the packet header.
No.
Or relative to the original sending time of the packet by the source.
Relative to the fact that the clocks don't drift, I think is what's going on here. You can have the routers independently believe it's 1 o'clock, 2 o'clock, and 3 o'clock, but as long as they all advance to 1 minute after the hour, 2 minutes after the hour, 3 minutes after the hour, because they don't drift, this should all work.
Okay, so the packet arrives. How do I as a router know whether it is early or late for the packet to have arrived at this point in time?
Indeed, the accumulated resistance deviation we termed as E. The field E can provide the information whether the packet is earlier or later.
So that is another field, the accumulated residency deviation. Is that another field in the header that is not per hop?
That is also covered in the packet. Is not.
Do you have any slide showing an example packet header so that we know what information is in the packet?
Curtis, it's on this slide. The packets carry D and E.
Yeah, I have a hard time. Okay, all right. Okay. Yeah, it's.
Updated every hop, but the D is not.
Yeah, the D is a fixed value that is computed by the controller or the head end for the service flow.
D is a constant, but the E is updated every hop.
Okay.
Yes.
A quick comment for the requirements draft. I think the material in the requirements draft on synchronization ought to capture not just clock synchronization or lack there, or the requirement or absence requirement for clock synchronization, but also we've now seen two of these mechanisms that don't require wall clock time synchronization, but do assume that there's effectively no skew in the advance rates of the clocks. That would be good to capture in the requirements draft if it's not already there.
Can you restate that again? Sorry for the notes.
Okay, so when we talk about clock synchronization, we're usually talking about wall clock time synchronization. And we have a really important requirement in the requirements draft that says we don't require wall clock time synchronization. And what we've seen now is that clock skew or rate of advance needs to be aligned for the two mechanisms we've seen so far that don't do that don't need the wall clock time synchronization. They do need the rates to match, the rates of advance to match. I hope I said something in there that'll be coherent in the notes. Maybe Pascal's got a better way to say it. Go ahead, Pascal.
Yes, I think I've seen the word synchronization for saying this. I mean, you don't have the same hour on the clock, but your tick is aligned. And that's synchronization, as opposed to synchronization.
Yeah, and I think this algorithm and the one that we saw from Genu are both depending on that. And you do this with high quality crystal oscillators, for example. If you can get them to independently advance at the same rate by carefully controlling what's going on there.
So the way I understand clock synchronization is that your wall can be arbitrary, but clock synchronization actually means that over arbitrary periods of time, the difference between these two clocks that you're comparing, that you're synchronizing against each other, will not differ more than a maximum. That's the so-called maximum time interval error, MTIE. That's clock synchronization. When you do allow that over long periods of time, the MTIE also becomes larger and larger, which I think is what you call clock skew, then people are typically talking about only frequency synchronization to a certain degree of accuracy.
Frequency synchronization would be an excellent pair of words to put in the notes, please. And Florian said the same thing, so that would be excellent in chat. Thank you, Florian. Jinu, you're in the queue. You wanted to say something?
Yeah, this is just for the question for clarification, because I'm not sure. If so, in order to get the accumulated residence time, or simply put, accumulated delay so far, is it easy for get the time synchronization, or just to calculate all the delays in every node, how long the packet has been in that node, and put into the header? Yeah, which one is easier, do you think? I'm not sure.
Is the question? Oh, okay. I will see that. Calculate every node.
One was, what do you think? What have you had in your mind in order to get the accumulated delay so far? Did you intend to calculate every delay at every node and accumulate them in the packet header, or simply just get time
Yes.
synchronized and all over the which one is easier, do you think?
Yeah, we
I'm not sure. Yeah.
will get. Yeah, we will get the accumulated residence time deviation. In fact, that is computed again by the real accumulated residence minus the planned residence time.
Yeah. So Jinu, he's updating the deviation from plan at each node as he goes along.
Yeah, we will update it.
Okay.
Yeah. I don't know which is easier. That's just simply what he's proposing to do.
I
All
think
right. If
one place where we could get an answer from Ginu's question would be the IOAM people, which I think are also updating for every packet with an IOAM field, potentially header fields. That might be one data point to collect information.
Yeah. What I'm thinking is that if you want to measure the delay of your own, you have to wait until the very last moment of the transmission, and then you have to write it.
That is
I'm
not
not
necessarily
sure.
true,
Yeah.
right? You can if you can calculate the residency time in a particular queue based on what for example is counted in the queue, you can calculate the departure time potentially earlier.
okay, hearing silence, I think we are at time, and I'm going to
Can
say that we're
a quick process thing. Can we make sure that we get the slides somewhere and put them up?
yes, I'll get the slides somewhere and put them up. I might even put slide numbers into them before I put them up.
Thank you.
Yes, the slides will go up. I don't know about immediately, but I'll get them up.
Sure.
Okay, I think we're done. Wonder if do I need to do anything to terminate the meeting? I suspect that when I leave the room, the meeting terminates. We're all done. Thank you all very much. Next meeting will be in about 2 weeks, and please take a look at the notes in Hedge Doc to see whether what you said was captured correctly.
Thank you.
Okay, thank you.
Thank you, everybody.
Thank you.
Thank you.
Bye bye.